So first of all, let's start off by talking about the different types of cables. First one being twisted pair. Now, twisted pair cable is something that's been around for a very long time. And some people actually refer to it as telephone cable, okay, because that is the technology that the telephone network has used for a very long time. Your typical telephone wire is a twisted pair wire. Now, there are different categories of this cable, and they are called just category and then a number, or sometimes abbreviated as just CAT for category. So some of our older cable was Cat3 cable, and this operated at a maximum of 10 megabits per second. Okay, so that's how much data could actually travel along the cable. Back in the 90s, we were still working with 10 megabit networks because we would have Cat3 cable. As we got into the later 90s, we moved up to Cat5 cable, where we now could communicate at 100 megabits per second. And we've more recently moved into Cat5e and then Cat6, which gives us 1,000 megabits per second, or what some people refer to as gigabit transmission. Now, regardless of the speed that the data can travel, all of the different cables can have data travel up to 100 meters before suffering from something called attenuation, which is basically a degradation of the signal, because the signal as it's traveling across that cable eventually is going to fade away. The best way to describe it would be if I were to be standing a few feet from you and I'm talking to you, you can hear me. But if you start walking away from me and I just continue talking, eventually the sound of my voice is going to dissipate and not make it all the way to your ears. That's kind of like what we're talking about here with attenuation. This particular data can travel on a twisted pair cable for up to 100 meters before suffering from possible attenuation. Now, there are two different types of twisted pair cable. We have unshielded twisted pair, or UTP, which is susceptible to something called EMI, electromagnetic interference. When you have electricity traveling on a copper wire, which I will tell you, twisted pair cabling is copper wire, there can be interference from either other wires that are traveling in the same area, or if you had other major magnetic or even just other energy in close enough proximity to the wire. One very good example that we actually see this fairly often is when you have wires traveling too close to fluorescent lights. Fluorescent lights sometimes give off EMI. Or if we have just too many cables all running together in parallel with each other, you get what's called crosstalk, and that's the electromagnetic interference. If we are working in an environment where we have to be worried about EMI, then we can switch to the other type of twisted pair cabling, which is called shielded twisted pair, where we have an extra layer of foil wrapped around each of the twisted pairs of wires in the cable. And that extra layer of foil will protect against EMI. Now, if you look on the screen, the middle picture is an example of what unshielded twisted pair looks like if you were to cut open the cable. Okay, and by the way, unshielded twisted pair is the most common form of twisted pair cable that's out there. Okay, in other words, if you just go to the store and you say, I want to just go buy one of these twisted pair cables, you're going to get unshielded twisted pair. You would have to specifically make a request or look for shielded twisted pair, typically in order to have that wire. Now, if you look carefully at the bottom picture that I have here, you'll notice that each of the twisted pairs have some foil wrapped around them, and that's shielded twisted pair. Okay, so that's what it would look like on the inside of that cable. Now, twisted pair cabling uses what's called an RJ45 connector. And if you look at the top picture, you'll notice it might look like a telephone jack. Right? That's what a lot of people will look at. It looks like a large telephone jack. Well, that's exactly what it is. It's a large telephone jack. Why? Well, because this is telephone cable. The only difference between an RJ45, which is this connector, and an RJ11, which is your typical telephone connector, is the number of wires that it can hold on to. Now, there's one other really important point that we're kind of missing here, and that is, why the heck is it twisted pairs, right? Why are the wires twisted? Well, I mentioned that when you have multiple wires running in parallel with each other, that you can get what's called crosstalk. The way you avoid that crosstalk is by twisting the wires around each other. Okay, so it's only if they were pulled straight and in parallel with each other. So when we talk about interference or crosstalk coming from other cables, that might be if we had a lot of these cables, or if we had other electrical cables, maybe even different types of electrical cables, all running in parallel with each other in very, very close proximity to each other. I mean, they'd have to really be like tied together. Again, these days, cables are built quite well, and there is a certain level of shielding that's always involved, even in the most generic of cables. So crosstalk is not nearly the issue that it once was.